Hello, everyone. Thank you for joining us for the fifth episode of our Python web app series, Containerization with Docker. My name's Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. And while we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on the chat. We'll be dropping helpful links and checking for questions for our presenter to answer live. Our session is being recorded. It'll be available to view on demand within 24 to 48 hours right here on our Microsoft Reactor channel. With that, I'd love to turn it over to Pamela. Pamela, thank you so much for joining us once again today.
Hello, hello. Thank you everyone for joining us again for Containerization. This is our fifth episode in the Python web app series. And we just have one more after this on testing. So today we're going to be talking about all sorts of things containers. If you haven't met me before in our previous streams, I am Pamela Fox. I'm a Python cloud advocate at Microsoft. I've been here the last few years. Before being at Microsoft, I was at UC Berkeley as a lecturer. I was one of the first engineers at Coursera as a full stack JavaScript and Python. I was at Khan Academy, where I created most of the computer programming courses back then, as well as being a Python JavaScript engineer. And I was also one of the first developer advocates at Google, working on the Maps API and later App Engine, where I, once again, got to play with Python. So throughout my career, I have basically been a Python plus JavaScript developer. And the last few years, I've really focused quite a bit on Python and specifically how we can build web apps with Python and, of course, web apps using AI in the last few years. So today we're going to be doing an intro to Docker and seeing how we can build and run a basic Docker container. Then we're going to talk about how we can use databases with containers. And then finally, we're going to be deploying a containerized app into Azure. Now, if you do want to follow along with what I'm doing, then I do recommend GitHub Codespaces. It's generally the easiest way to follow along. If you do want to develop locally, then you are going to need Docker Desktop. That's the big thing you need, is a way to run these Docker things. That would be the main requirement. So, if you do Codespaces, it'll be set up for you. If you're going to do local, make sure you've got Docker Desktop and you start downloading that now if you don't have it yet, because it can take a little bit of time to set up. These are the two main repos that I'll be demonstrating in. So akka.ms/flask-container and akka.ms/flask-db-container. If you are going to be following along, I recommend going to the repos now and setting up the code space, because it can take some time to set up. So you go to the code button and go to the code spaces tab and then create a new code space on the main branch. So I would recommend doing that for both of these repos if you do want to follow along. Of course, you're also just welcome to watch and, hang out in the chat. So let's start off with Docker 101. Now, if you've already had experience with Docker, that's totally cool too. You can help answer questions in the chat, and you can also post in the chat what your experience has been like with Docker and what you're using it with to share what that's been like for you. So let's talk about Docker overall. So what we have is we've got our computer, and our computer is running on some particular hardware, right? Like I've got a Mac OS with an M1 chip, for example. A lot of my colleagues at Microsoft have Windows machines with whatever chips those have, Intel chips, right? And so we've got our hardware, we've got the operating system on top. And then we have a Docker engine. If we install Docker, we have that Docker engine running on top of the operating system. And as long as we have a Docker engine, we can run Docker containers. And each of those containers is a fully isolated environment. And those environments can run completely different application code and libraries and languages and databases, and everything can be separated in those two environments. So for example, we could be running, in one container, it could be Python Django plus, Postgres, maybe it's Python 3.12. And then another container could be Ruby on Rails MySQL. Or you could even have like container A, which is Python 3.11 plus Django plus Postgres, container B, which is Python 3.10 plus, Postgres, like a different version, right? That's actually the even better use case for Docker, where you have environments that would otherwise be really hard to run all on your same machine, right? And that's where we get like a lot of the pain, right? Like if you're a Python developer, it's like, well, I've got one repo that's, moved to 3.12. I've got another repo still in 3.9. I've got this other repo that's using Postgres 14. Another one's using Postgres 15. Running those all on the same machine in the same environment can be really, really hard. But if we use Docker containers, then we can run each of the containers separately with their isolated environments. And there it's totally fine that you've got a different Python version and a different Postgres version, because they are each inside their own isolated environment with their own software packages running. So there's many benefits to using Docker, right? One of the big benefits that people love about Docker is consistency environments, right? If you set something up using Docker, then you can, in theory, have consistency between your developer environment, your test environment, your staging environment, and your production environment. Now, in practicality, there usually are going to be differences between your development environment and your production environment, just because some things don't scale, up to production, and use different things, different API keys, that sort of stuff. But you can have a lot more consistency between those environments than what you could have before. It's also a lot of consistency across developers on a team, right? So imagine you join a company and you've got some colleagues that love using Linux boxes, and some people love using Macs, and some people love using Windows. Well, if you're trying to make sure everybody's able to develop the website, then you want to ideally have a consistent developer environment. And the one way to do that is to use Docker containers and say, listen, it's fine that everybody is using a different operating system. Everyone's using what they like the most. All of you have Docker engine, and so you can just use this Docker container as your developer environment, right? So it can be really nice from a developer experience perspective when you're inside a company and you're all trying to have a consistent experience for developing the same piece of software together, even if your operating systems and hardwares are slightly different. Now, in terms of like the benefits for production, because we use Docker containers in production quite a bit as well. And that's because they're very, very portable, right? So if we have a Docker image, Docker container, we can easily run that application on new hardware, right? So imagine that, our computer that had our server got hit by lightning and now it's done, right? Well, we just have to pull up a new computer and run that same Docker container on the new computer. So we have this application portability. We also can be more efficient with our use of computers, right? Imagine, once again, we're in the data center, we have that computer is acting as a server. In the past, usually you would like rent a whole computer, and that would be your computer to run your stuff. And the reason you do that is because then you can like really set up the computer for your own needs. But if you're using a Docker container, then that computer can easily support running multiple people's, multiple applications, because they're all using containers, and it can just slice out, parts of the machine's resources for each of those containers. So we can more efficiently use hardware if we're using containerized environments, because we can run multiple containers on the same computer. So there's like an environmental story to containerization too, which is great, because it's always nice when we can do something that's better for the environment. So how does it actually work? Let's get into some terminology. All right. So the thing that is running is called the Docker container. That's the actual thing that is running. And that is based off a container image. So the image is the software package that includes everything needed to run the application. And so you can have a single container image, and then you can run multiple instances of that image, and that's what's called a container. So the first step is actually to come up with the image, right? You say, this is the image. Okay, I've got Django, I've got Postgres, I've got these additional Django extensions, and they're all bundled in this image. And now based off that image, you can run one container, you can run two containers, you can run run the containers on top of different Docker engines on different OSs. So you build that image first, and that gives you the ability to run containers based off that image. And here's the example here where we have, multiple containers running from that same image. So how do we make these images, or how do we find these images? So one thing that you're going to be using is called an image registry. And that is a place where you go to get images. The most popular one is Docker Hub. And so this is where we usually go to get our base image, and then we're going to build an image based off it, right? So Docker Hub has a huge number of the most common base images, right? So if I just search for Python here, and here I can see that there's the Python base image, right? And an image, so this is the image. The image also has a bunch of tags. So the actual image is really like the tag, because this one, if you look at Python, we've got like a Python 3.10, Python Alpine, Python 3.13, which is the pre-release version of it. So you can try out Python 3.13 from these Docker images as well, 3.11, right? So these are all the most popular tags for Python. So if we want to, build a Python environment, we can start from this Python image. Now, similarly, if we want to run Postgres in a container, we could also look for a Postgres image, and that has it all set up. So a lot of times we do start off from these official images if we're, doing something somewhat standard. And you can see, a lot of popular things here like Nginx, Python, Terrific, Node, right? And we're going to often build an image based off of that. And we're going to use a Docker file to build that image, to answer a question in the chat. And we're going to see how to write that Docker file soon. So we can look at like one of these, and let me look at the Postgres image. And it's really, really cool actually on Docker Hub. You can actually, so each of these is also written with a Docker file, and you can actually see the Docker file here. So we'll get into this format, but you can see how this was built. So the Postgres image itself was built on the Debian image. So Debian is a popular Ubuntu flavor that's used quite a bit in Docker files. So we can see that, okay, Postgres pulls from the Debian Bullseye Slim image. And then it, brings in a bunch of things on top. So in order to set up Postgres, you can see everything that goes into it. So on this Docker Hub registry is very cool because you can see everything that went into it. You can look at potential vulnerabilities. Anything it determines is a potential vulnerability in this particular Docker file. You can look at every single package that's included in it. Like if you're wondering, like, oh, does this one have Git? And I'm not sure if it does have Git actually. Because I guess it's Bullseye Slim. I think Slim might not have it, but yeah, so you can look through there and see everything that is included. And so same thing with the Python. We can look at this, go to the tags, look at like 3.10 Alpine, and you can see it was based off the Alpine image. And then it does a bunch of things to set up Python and to set up pip so that you're able to run pip because that's so common. And then you can see, all the additional packages. So definitely take advantage of Docker Hub when you're looking for base images to start off from. Now, there's also registries that you can use to store your own images once you've created your own images. So we'll talk about how we can create our own images. So generally, every image starts off with a base image. So like we saw for the ones in Docker Hub, you could see like, oh, this one starts off from this Alpine image. The other one we were looking at started off from that Debian image, right? So everything starts off with a base image, and most of them start off with some sort of Ubuntu flavor. And then they add layers on top of it, right? So one layer might be adding in Python support. Another layer might be adding in Flask support. Another layer might add in additional requirements. Another layer might be installing your application code. But you can generally think of an image as being a base image plus layers on top in order to make your image increasingly more specific for your application. And the reason we do it in this order is because Docker can actually cache each layer, and that can improve performance when we're, building and iterating with our Docker files. So you generally want to start with, what's the most, generic thing, which is like, oh, okay, you're using Ubuntu, and then you go on and add layers that increasingly are specific to your application. All right, so let's see how we would actually make an image for a Python app. So in order to do that, we need to write a Docker file. Then we need to build the image from that Docker file, and then finally run a container using that built image. So inside a Docker file, the first line is going to say what the base image is. So in this case, generally, my base image for a Python web app is going to be one of the Python base images. And you saw there were a lot of different tags we can choose from. So if we know that we're okay with Slim and we want to use Slim, then we can do that. It just depends on what you're going to need access to and what additional packages get installed. But you saw there were a ton of different tags for Python, so you can really get really specific when you're picking that base image. But here we're getting Python 3.12, and we can look here and see. We can just sort by let's see. You can do 3.12 filter, and this one 3.12.4. Can I just do like this? I was trying to just go direct to it. 3.12 Slim, 3.12. There we go. This is the one. So this is the one it would pull in if we just said from Python 3.12. And we can look at it and see that it's based off of Debian 12, the Bookworm version, and some additional stuff. All right. And then after that, we're going to be installing things onto this machine. So our next line is going to install Flask and Unicorn, because that is what we need to build a Flask application. So that's our example, is going to be building a Flask web app and running it with the Unicorn server in production. Then we need to copy over our application code. So the way we generally do this is we say, create a working directory inside this image that is the code folder, and now copy everything inside this current folder into that code folder. So work directory, this command here, it actually does two things. It makes this directory, and then it basically CDs into it. It goes into that directory and basically makes that directory be the current place where we're working from for the rest of the file. So we are now in, we've made that /code folder, and now we're doing everything from that /code folder. So we copy everything that's currently in our, our folder into that code folder on the image. We expose a port so that this gets exposed on the, on the Docker network, so that we could actually hit up that port. So we do, when we're making a web app, we generally need to expose a port so that we can actually, access that server at the port. And then we specify the command that's going to be run when the container launches. So this last one's a little different from the other ones, because these ones are all going to be building the image. And actually, these two both really have to do with when you actually run a container, right? So when you run the container, this port will be exposed and this command will be run. This command is not going to be run when it just builds the image. It's only going to be run when a container is actually run based off this image. Okay, so let's actually just try this out. So here's the complete file here. And I did it slightly differently, and I'll explain. So if you're following along, I'm doing this in aka.ms/flask-container. And it actually already has the Docker file, but I've deleted it so I can show you from scratch, right? So I'm going to make the Docker file. And we have the from Python, we make the work directory. Now, I did something a little different here, which is the first thing I did was copy requirements.txt into that working directory, and then pip install based off the requirements.txt. And then after that, I copied the application code. So the reason that we do this funny thing where we first copy over requirements and then copy over everything else is because of the layer caching. Because requirements.txt is going to change a lot less frequently than the actual application code. And we want to generally keep in mind Docker layer caching and be able to take advantage of it. So if we know that, a particular step is going to change a lot less frequently than another step, then it makes sense to break them up and do that in that order, right? So let's actually, I can demonstrate that when we actually build this, and we can see the performance of it. So then we do a pip install, and you can see requirements.txt has Flask and Unicorn. And then we copy over the rest of the code. We tell it we're going to expose this port. And then this is our entry point command. So this is, basically going to do the equivalent of concatenating this all together with spaces. So gunicorn-c, gunicorn.conf.py app. So this is the command to run gunicorn, which is a way to run Python web apps in production. So they can handle multiple processes. So now we've got our Docker file. So the next step is to build this Docker file. Actually, first we're going to add a Docker ignore. So just like we have git ignore to tell git what to ignore, we also want a Docker ignore. And this way it's not going to copy stuff that's in the Docker ignore, right? Because we don't want to copy in our .git or any virtual environment or cache files like PIC or PyCache. So you're going to put anything in your Docker ignore that doesn't need to be, that should be completely ignored by this copy command. And it's just easiest to be able to have it in your Docker ignore. Okay, so now this copy command should ignore everything that's in the Docker ignore. And then the next step is going to be to build the image. So let's first do this from the command. All right. So at this point, all we have is a Docker file. We don't yet have an image or a container. All we have is the Docker file. We need to take this Docker file and use it to build an image. And an image is the thing that's actually going to contain all of this stuff in it, and that will actually take up storage space. So we'll see this when we build it. So Docker build, we can watch it go layer by layer. You can actually see like here's the first layer, 1 out of 5. So it says from Docker 3.12. And you can see it bringing it all down. Then it says 2.5 is work directory code. 3.5 is copy requirements.txt. 4 out of 5 is run the pip install. 5 out of 5 is copying the rest. So those were the 5 steps, the 5 layers that it went through when it was building this image. And so now we can see the image is built. And I've got the Docker extension for VS Code. So if you're opening this in a code space or if you're in VS Code, if you have that Docker extension, you can actually go and you see whatever that was built over here. So let's see, I already built it before, but let's look at, let's see, inspect this. Yeah, you can see kind of what it's made of here. I wanted to show if I could get the size of it, but let me show you actually just the same thing locally. So if you are doing this locally, you can open up Docker Desktop and let's see if I've got this built locally right now. Okay, let me build it locally as well. All right, so I'll just build the same one here locally. Okay, and now that should be in our local Docker as well. So we can see FastAPI. Yeah. So what I wanted to show you is that this has a size. It has a size. Let me make it bigger. So FastAPI, it has a size of 1 gigabyte. So this is where this is actually containing all of the layers, right? So the images are the things that really take up size on your machine. And sometimes I have to clear out my images because I have too many. I've got this great disk usage extension, which I definitely recommend. If you have Docker Desktop, you got to enable this extension. It's really nice. It'll give you a pie chart. We all love pie charts, right? And it'll tell you like, okay, my images are taking up 18 gigs. My containers are taking up 8 gigs. So it's, my images always take up more. Build cache is taking up a gig. Volumes, we'll talk about those soon. And it gives me an easy way to reclaim space. And I can decide what sort of things I'm okay with getting rid of and, what things I want to keep around. But, what I want to show is that here we've made the image and now you can see it shows up with all of our other images. And that, is what is really taking up space here. So we've got the image. What we don't have yet is a container that's running based off of this image. So this image is just a bundle of code on our machine or in our code space. It's not running anywhere. Nothing is executing. So if we want to actually run this code and run this entry point, we need to run that image. So the next step is going to be a Docker run. So we tell it the name of the image that we made, and we also tell it if we want to publish any ports. And so there we're saying like, okay, if 505 is exposed inside this, I also want you to expose that as 50505 on the, the local network as well. So I tell it to run, and here you can see it's showing the gunicorn logs. So it spun up that image and ran this entry point command. And now I can open this this local server here. And this is the website. It's a very simple website to start off, just to show that it is working. So there you go. It's working. Remember, we can run multiple. So if we wanted to, we could do this again. So let me show you, like if you're in VS Code, you can also right click and run, run on here. In this case, actually, I can't run multiple because I have a port collision because I've specified the 505 port. But I can, let me do a different port. So let's see. All right, so let me publish 50505. I have to always remember which one's the external port and which one's the internal port. Let's try this one. Okay, so that worked. So here I've told it to take the 50505 internal port to the container, like what's in the Docker file, and it's publishing on, this one should be publishing on 50105. Let's see. Yeah. So this is actually getting published on 50105. So now I'm running two containers. I've got two containers. Let me expand here. There's three just because I was doing stuff earlier, but there's two of the Flask app running. And, we can see it shows that there's two containers running here, and then I can, open them up. And this is actually running on two different ports, two different URLs. So this one's on 50515 and this one's on 50505. So that's what we mean, is that we have one image, right? So this is the image and we're using the latest tag. And then we're running multiple containers based off that image. And I know there were like various questions about running versus building. So hopefully that helped. But if there's still questions, please do post them. Now let's see what we mean about, the Docker cache layers. Let's play around a little bit with rebuilding. So I'm going to go ahead and close, close some of these processes here. Let's close that. Okay. All right. So I think now, did I shut everything down yet? Let me just, you can also just tell from your Docker desktop or from your VS Code extension, you can tell it to stop. All right. So now let's see what would happen if I just change the application code, right? So if I go here and let's just change the index, and we'll add some more emojis. We got a whale with some Python. Okay. And so now I've changed that. So I've changed the application code. So now let's try building again. So we'll go back to our build command here. And what we should see is that a bunch of layers were cached. So see how it says cached this one, cached this one, cached this one. And so the only one it actually had to redo was that copy command. So that's why we separated our app code from requirements.txt, because it was able to cache the pip install, and pip install can take a really long time. Actually, like I have some of my apps which have a huge number of requirements take like 15 minutes to pip install. They probably have too many requirements, but that can take a long time. So the fact that you can cache that is really nice. Now let's try changing the requirements. Like if we went down to 3.0.2, right? And now if we rebuild, we should see that it's no longer caching that step, right? So it did cache, making a code directory, but it wasn't able to cache the requirements. And so once it can't use the cache, it has to redo everything from that point, right? It can't, because it has to assume that at that point, everything will have changed onwards, right? So the fact that requirements.txt changed means it also has to redo copy ... It'll redo everything from there onward. So that's why, the sequence of your Docker file does matter. and why you might see people splitting things up in the Docker file in a way that surprises you. You might say like, oh, why don't we just do all in one command? And they might say like, well, this part of the Docker file really doesn't change very much, so we're going to do this, we're going to break it up and do it separately. You might also hear about like multi-stage Docker builds, which is similar. Let's see. Okay, so hopefully that answers some of the questions. And just to show also, if you have the Docker extension for VS Code, you can also just right click on a Docker file and say build image. Apparently you can even build image in Azure. I've never tried that, but you can definitely just right click and say build image, and I'll just give it the name similar, the same name as we were giving it. And so that'll also run the command. In this case, they're all cached, so it was pretty fast. So that will, give that image there. And then, also with Docker Desktop, we can do lots of things as well. So, if you've got this thing here, you can click on it. You can see all the layers actually. So it's even showing you the Python layers, and you can go ahead and run it from Docker Desktop as well, right? And we can do settings here. So we might say like, okay, we're gonna assign it to 50505 and blah. Okay, that should be good. And there you can see, and here it's actually running with a huge number of workers, because our Unicorn will run with workers based off the number of CPUs that are available. And my Mac actually has a good number of CPUs available, apparently, because it's running 20. It's running quite a lot of workers there. So you can see how that's different when it's running on this hardware here. So there we go. So this is running off my local machine. So now I've got this, 000-50505 URL. So there's many ways that you can use Docker, right? You can use it via the Docker VS Code extension. You can use it via the command line. You can use it via the Docker desktop app. It's good to try out all of those to see which way you like the most. Okay. So there we go. So we've already done some stuff with this, with this container. But let's see what else I suggested. Oh yeah, let's also try changing the base image. So we haven't done that yet, right? So if we change the base image, like let's say, we have to downgrade to 311 for some reason, right? And then if we build this one, we would expect that this is going to be a lot slower because nothing can be cached. So I think it did actually have to be fair, it had 311 before, because I've been using this environment all day. So that wasn't actually that slow, but let's go find another, let's do like 3.8. That's really old. Okay, let's try 3.9. I don't think I've got 3.9 in the local image cache, because also Docker has, an image cache of any base images it's pulled before, because it thinks it's likely you'll want to use them again. So here, this one, 3.9, isn't one I've used at all in this environment. So it had to pull it completely from scratch and then do everything else from scratch as well. Now let's try 3.13. See what happens here. 3.13 completely fails, because what we see is that it says 3.13 not found. So if you get an error like that, you would want to go to the, the thing here. And the reason it's not found is because 3.13 is a pre-release right now. So they don't have just a straight up 3.13, because they don't want you to accidentally use it. But if you did really want to test yours with 3.13, you could grab one of these specific images and try it out. Like this. Okay. And then this time, this one should actually build. Yeah. And so then that one all builds. So the other cool thing here is that it's so easy to switch in different Python versions and do tests to see okay, is our app working with this other version of Python? Will we be able to upgrade to it? All right. So now let's talk about databases and containers, and how do we actually use databases with containers. And as it turns out, there's a very different story for local versus production. So we'll start off with tackling local database usage. We're going to be moving on to the next repo, which is aka.ms//fastdb-container. So let me go ahead and open that one up here. I've got a code space going for it. Let me close some things. And this one, let me share a live deployed version of it. This is a survey app, and I've set up a survey for all of you to actually answer. And it is, what color should I dye my hair? So if people actually use this survey, and we'll put the ACA in the chat. If you use this survey, then you can decide what my next hair color will be. I am putting it in your hands, and then you have to tune in to our next series in July. We have 2 series coming up in July. So Victor, who's in the chat, Victor has a Spanish version of this series. And then I'll be doing a securing AI apps in Azure series. So if you tune into that AI app series, then I will presumably have a new color hair. I forgot to just keep it the same as an option here. So I guess it's not an option. I was going to put that as an option. I guess it's not an option. So I guess I will be dyeing my hair. So yeah, so fill that out, and don't hack it too much. Just one entry per user. So I actually already filled it out in the main tab. Let's see what we're at right now. Oh, silver. Wow. That'd be cool. I've actually never properly done silver. It's pretty hard to do. You have to like really tone it. Well, that's exciting. All right. We should have also done bets before and what would win. Okay. So keep filling that out, and I'll check it at the end so we can see what the winner is. See what I have to get on Amazon. All right, so that is the container app that we're going to be working off here. So I've got it open in this code space. So this is an app that is storing the survey questions and answers in a database. So it can store multiple surveys. If you go back to the main page, you can see like other test surveys that I've done in the past. I don't even know what this one is. It's all blank. It's a great survey. But it's storing these surveys in a Postgres database, and it's got a table for questions and tables for surveys. So how do we actually do data persistence in containers? It's actually a bit tricky. So you might start off by saying like, well, can I just, put the database in the container? Can I just write data into the container's file system? Now you can, but the issue there is that if you remove the container, like if you just, stop running your container, delete your container, then your data is gone, right? It's also just difficult to move data between different containers, right? Because you saw I could really easily run multiple containers based off a single image. But a lot of times if I'm running multiple containers, I might actually want to be using the same database between those containers. If I'm just like, imagine I'm just running multiple containers in order to do like scaling or testing a different like UI parameter or something like that, right? The other issue is that generally container storage drives are less performant than you want for a database. If you're if you're trying to do a database, you generally want, good performance to be able to do reads and writes at a reasonable speed. And container storage drives aren't necessarily optimized for that sort of usage. So what that means is that if you do need to persist data, then you should store it outside of the container. So for local development, what we're going to use is called a Docker volume. It is a directory on the host machine that is mapped to a directory in the container so that it kind of acts like it's isolated, but it is actually on the host machine, which means that it's there even when the container isn't there. So that way, if you do, spin down a container and stop a container, your volume, the data in that volume isn't going to go away. And then if you spin that container back up or spin back, multiple containers, it can access the data in that volume. So that's what we're going to use for local development. So let's see how we can actually do that. So first we're going to do the super slow and annoying way, and then we're going to do it the awesome way. So bear with me with the slow way if you already know the awesome way, because I just want to like show you both ways. So the first thing we're going to do is create the volume. All right. And so let me go here and I say Docker volume create. So I'm creating this volume to store our Postgres data. And then we're going to create a network. This is an internal Docker network that is for the Postgres container and the app container to talk over. So we need them to have an internal network for them to talk with each other. So we're going to create this Postgres net. And in this case, I actually already made it because I went through these steps earlier. So that is already there. And actually, I can open up let me find my Docker. And let me just go ahead and delete that so that we can, do it fresh. And there you can see we created it. And now it shows up in our networks area of the Docker extension. And we can also see a volumes area. So we can see this Postgres data volume that we created in this step here. And then the next step is that we're going to actually run a Postgres container. So that's using the Postgres image. And we're going to run it using the volume and the network that we just created. So what we do is we're telling it to run the Postgres image. So that's from Docker Hub. We tell it what username and password to use. And we've set that up locally to match our code. We telling it what network to use. And that's the network that we just made. So you see this matches this. We tell it what volume it's going to be using. So we're saying that Postgres data is going to map to var/lib/Postgres data on our host machine. And in this case, our host machine is a code space. Okay, so then we're going to do that. All right, so now it should be running a Postgres. We can look up here. And actually, let me go ahead and just remove ones I've done before, just so we can see what's running from that. Okay, so here Postgres is running. So we're currently running a Postgres database that is using the network and the volume that we created. Now we need to run our app code and have it communicate with that Postgres database. So in order to do that, we need to set up the environment variables so that it connects using the same connection details. So we have in our source folder, we make this .env file. So that says the host, the name, the user, the password. So this matches what we specified to the Postgres image. And then the DB host, this is interesting. This is actually the name of the Docker network. You can see here where I said name DB. So I named this container. So we can see that they're on the same network. It's going to access it via its container name. So this is the name of the container, because normally this would be like localhost if we were doing this a normal way. But since we're setting this up as a container, the host is the name of the container. So it matches what we named that Postgres container. And you can see the name of it here as well, DB. All right, and then we're going to build the container for the app. So we're going to go inside the source folder, because that's, in this case, I put the Docker file for the app inside the source folder. So here's the Docker file for the app. It looks similar. It's a little bit different. We're going 3.11. We're installing some requirements, installing a couple of other things that are helpful, doing some stuff, fancy stuff with users. Okay, and exposing the port, and then running an entry point command. In this case, I'm actually pointing at a shell script. So that's another way that you can do entry points, is that you can point at a shell script that you've got locally as well. All right, so I am in that source folder. So I'm going to go ahead and build the application container. So now I've got an image, right? And if we look at our images, we've got a bunch, because I guess I've been doing this all day, but we've got an image made. And now we need to run that image. So we're going to run that image. We're going to run it on the same network as the Postgres container. And Yeah, and that's the key, actually, is just running on that same network. That's the main difference that we're doing here. All right, moment of truth. It looks like it has connected fine to the Postgres server. I'll open it up here. And here we can see this is it running locally. It doesn't have any surveys yet because it starts off with no surveys. So we can be like, like cool languages. What's your fave? And be like Python, JavaScript, Python. All right, there we go. Totally unbiased survey. And there we can, create that. We can create what's basically a couple rows in a database table. So this is working. So we've connected the app container to the Postgres container. They are both connected because they are using the same network. So they're over this Postgres network. And the data is being stored in a volume in Postgres data. So let me prove that the data is in a volume, because I'm going to go ahead and stop running this. And actually, I could stop running the Postgres one too. So let me just go ahead and remove it. I'll just remove that Postgres container entirely, right? And let me remove. So I'm going to start from scratch, removed both of them. Let me go and run the Postgres again. So now that's running. We can see it running here. And then I'm going to go ahead and run the app container. Okay, it's running. Now, what I hope is that we're going to see the data still there. There we go. So what we see is that we still have that survey that I put in there before. So even though I completely deleted those two containers and created them fresh, we're still getting the same data because we're using the volume, and the volume is actually on the host machine. So we're able to have this data persistence, regardless of whether we're removing and restarting containers. So that's really nice for our local development story. Okay. So that worked. That was kind of painful. That was a lot of steps, right? It's very easy to get those steps wrong. I'm kind of surprised I got them right today. So let's go ahead and see how we can improve the situation. If you already know the solution, go ahead and reveal it in the chat. This is a good time for spoilers. And here it is. So what we're going to use is Docker Compose. It is a tool for defining and running multi-container Docker apps that makes it easy to declare and define all those steps that I just did. So we can declare it once in a YAML file, and then it's super easy to get all of that running up at the same time. So let's go ahead and look at this Docker Compose.yaml. So this is basically doing everything we just did, and actually it's even doing a little bit more. So I guess high level is what we have in here is services, volumes, and networks. So we declared that Postgres data volume. So that's equivalent of Docker volume create Postgres data. We declare the Postgres net. So that's equivalent of Docker network create Postgres net, right? So we have these. And then we have our two services, and these correspond to containers that are going to be running. And we need these services to, be talking with each other. So let's look at app. So app is going to build using the Docker file that's in source. That's what this says here, is like build this container using the Docker file in this source folder. Use this as the entry point. So that's something cool with Docker Compose, is that you can override the entry point. So in this case, I've actually overridden it with entry point-dev, which is an entry point file that's a little better for development. This one has a -- reload. So that way, if I'm making changes to my code, it'll auto reload it. We have the env file that we created. We have the ports we're exposing. We have a volume actually for our application code as well. So we haven't talked about this yet, but if you want to be able to have auto reloading, like hot reloading while you're doing development, you actually also want to set up a volume for your application code, because that way what's going to happen is that if you're making code changes, it's it's going to be like synced from your actual like code folder, so that you don't want to have to rebuild a Docker image every single time you change your code. That's super, super annoying and slow, right? So what you can do is you set up a volume for your code, and that way, whenever your code changes, it's going to change in the code folder. So here we're saying map/source on my host machine to /code in the container. And that's how we can, get it so that we can keep writing new code changes and not have to build the image. But we also want to use -- reload so that we don't have to keep rerunning the server, right? So if you want hot reloading, you're going to want to have a reload for your server, and you're going to want to have a volume for your application code. Now, something interesting here. So we have the network, and that's what we specified when we were running before. A new thing we have here is this depends on. We want the application container to start only once the Postgres server is ready, because otherwise our application code is actually dependent on Postgres. Like, it needs to run the database and migrations and stuff. So we have added this depends on condition that says, hey, this app service shouldn't start up until Postgres is totally ready for it. And what we'll see is that we have to define a health check in our Postgres for that to work. So now let's look at our Postgres. This is based off the official Postgres image. So we don't have to have a Docker file for it. We're just straight pulling the Postgres image because we don't need anything special on top. We tell it this is like a restart mode, as if it dies, should it auto restart. We'd specify the environment variables that it's going to use. So we're setting it up with the Postgres password, user, and DB based off of the DB pass, DB user, and DB name, which are in the .env. We set up the volume, which is how we did it before. And then we add this health check, which checks to see, uses this PG is ready command, which is specific to Postgres. So for every service you do, your health check is going to be slightly different, right? Like Redis and Mongo, they're each going to have their own way of doing a health check, and hopefully they have some way of doing it, right? So in this case, there's this PG is ready function, and we can just keep pinging it. Like here we do every 5 seconds, we try 5 times. And, hopefully by the end of those 5 times, Postgres is ready, and we say this is healthy, and then the app container can build. So that is everything we want in order to have a good local experience with the app and Postgres. All right, so now let's try actually running that. So running this is actually pretty easy. We go back into the root and we just say docker compose up. And that's going to look for docker compose.yaml. And here you can see it starts at the DB first, because it can tell that needs to happen first because of that depends on, right? So it's starting up Postgres 16. It's setting up some database stuff. It says it's ready to accept connections. And only at that time do we set up the app and run that entry point, which does database migrations and then starts Unicorn listening on a port. So now we can go ahead and open that up and see that it is working. And this one actually, this must have a slightly different, does it have a different volume? Postgres data, var lib, Postgres data. So I think it must have a slightly different volume. Let's look at our volumes here. Volumes, Postgres data. Or maybe the database is different, actually. The database name might be different, just because we're seeing slightly different stuff. So it could be actually that my database name is different. But yeah, the cool thing is then we could do, so we can Control-C out of it. Or I know some people, sometimes you can get stuck trying to figure out how to get out of Docker Compose. So Control-C should hopefully work. You can also just Control-C a bunch of times. But you can also, in your Docker, whatever using Docker Desktop, Docker Extension, usually you can, right-click and stop things, right? So let me start it up again to show what it looks like to start up. And so you can see that these things become green, indicating that they're running. And then if we needed to, if we were having a hard time stopping it from here, we could also, go here and, just forcibly remove these from there. And that would also end the Docker Compose, because they have both exited here. But it can definitely be tricky, especially with Docker run. Sometimes I have a hard time Control-C out of a Docker run. just because of the way it interprets keyboard signals. So if you do have an issue like that where you just can't Control C out of something, remember you can also go to your Docker desktop or your Docker extension and then, right click on the container and stop it that way as well. All right, so that is Docker Compose. Docker Compose is super useful for local development, especially. And you can have really complicated Docker Composes that have lots of services. So you could bring in Redis, you could bring in Mongo, you can bring in any services that your app is built on. You could bring that into your Docker Compose. And the nice thing is that then you can just pass this Docker Compose around and say, hey, my fellow developers, my fellow colleagues, just Docker Compose up, and it's all going to be working for you. And there we go. All right, so what did we want to do? Right, so we can, so we've got this in reload mode. So since it's in reload mode, that should mean that we can make changes to the Python. And because we also have that app volume, it should just work. So we can go and let's see, routes.py, right? So I could go into here and say, okay, I'm going to order by survey.topic. Yeah. And then you can see it says worker reloading, right? And it says working reloading because this was modified. So what happened? There was a couple things. First, we're using the volume for our code. So the volume, was updated with our latest code because we mapped the volume from the Docker container to this folder here. And then GUnicorn is in reload mode, and it saw that our Python changed, and so it auto updated. So now if I go to my surveys app, it is ordered by name. Let's see, can I do? I think is it just negative? No, I think it's like .d. Let's see if I can remember how to use the ORM. We'll get an error if I did it wrong. Oh, there we go. Yeah. So I just switched the order. So you can see we've got hot reloading. So this is a really nice developer experience here. All right. So that is the local experience when working with databases. Now we're going to talk about how we can deploy containers to Azure and talk about what the production looks like for containers and for other services as well, because it's pretty different when you go to production, assuming you need scalability, right? So when we're thinking about hosting containers, as always, we need to be thinking about what's our budget? How much traffic do we expect? Do we need to be able to scale down to 0? Do we need to be able to scale up to hundreds of thousands? How much variability are we expecting? Do we want auto scaling rules? How much control do we want over the entire environment? We want to think about all of those things there. So on Azure, we have quite a few ways to host applications, and they all support containers. Some of them more obviously support containers, but actually, in fact, all of them support Docker containers because Docker containers are such a popular, way of packaging apps that at this point, it's been introduced into every one of our offerings, right? So the obvious ones that are very container oriented are Azure Kubernetes Service and Azure Container Apps. So Azure Kubernetes Service is actually Kubernetes, and Kubernetes is a orchestration framework for containers. I personally have not used it because it feels a little bit too sysops for me, and I just don't have those skills. Maybe one day I will. But if you are comfortable with Kubernetes, that's something you could look into. I typically use Azure Container Apps because containers in the title. It's very much optimized for containers. That's what it was built for. For this world where everybody wants to be able to host containers, and so that it's a very good fit for it. But if you really want to, you can also bring containers to Azure App Service or Azure Functions. We support it everywhere. So how do we do storage or data persistence in Azure Container Apps? So you can, technically, if you want temporary storage, you could write to the file system. You can even have something called an ephemeral volume, but those would both be temporary storage. So that's not going to work for a database. You do have a permanent storage option where you can mount Azure Files, basically as a volume, but Azure Files is not optimized to be used as a database. So we wouldn't want to use that for an actual relational database where we're going to be doing lots of reads and writes. So what we want to do generally with Azure Container Apps when we want to use a database like Postgres is that we're going to use a managed database service that lives completely outside the container and then just communicate, with that database server, using network calls. We've got a bunch of options on Azure for managed databases. These are just a few of them. So there's Azure Cosmos DB, which you can use with NoSQL API or MongoDB API. You can even use it with Postgres now for a huge amount of scaling vertically and horizontally. The one that I use the most often is Azure Database for Postgres Flexible Server, because it's pretty easy to get started and it does have vertical scaling. And yeah, it's just a nice Postgres offering. So this is what our architecture will look like when we are hosting on Azure Container Apps. So we're going to have what's called a Container Apps environment, and that's going to manage a container app. And that container app needs to pull an image from a registry. Now, you can have it pull images from all kinds of registries. You could have it pull from GitHub. You could have it pull from Docker. In this case, we're going to use Azure Container Registry. Since we're already using Azure for everything else, we might as well store our image in there. But if you did have a pre-existing image on another registry, you can totally pull an image from an existing registry. And then that container app is going to connect with the Postgres server over the internal Azure network. That's going to be the architecture that we're going to deploy so we can see how that works. When we do deployment, most of our samples are set up to use the Azure Developer CLI, which means that you can use this azd up command in order to deploy. So let's go ahead and try that out. See how slow it is to stop? Too slow. Just Control-C multiple times there. All right, and so now you can also make a new terminal. Like I saw a comment about a terminal being frozen. Another thing you can try is just making a brand new terminal. A lot of times in VS Code, I have multiple terminals. Now, if your VS Code is frozen entirely, that's a different issue. But a lot of times I'll have like a terminal where I'm running a server and then a terminal where I'm doing deployment. So in this terminal, I'm going to do azd auth login. And this is going to use, I'm in GitHub Codespaces, so it's going to use the device code flow in order to do login. So I'll go here and enter in that code and select my account and enter my password. And then I'm going to use my authenticator app. And it's going to look at my face. Okay, good. It liked my smile. And I'm finally logged in. There we go. So now I'm logged in. It's a lot easier when you're local, but in Codespaces, you have to go through quite a lot of hoops there. And now I can run azd. I'll do azd env new, so you can see making a brand new environment, or I'll just do azd env new to make a new azd environment. So Flask2, great name. So this is just the name for, it's going to become the name of the resource group that it makes, which is going to be the folder basically for all of the resources. Then I'll do azd up. And what this is doing, it's looking at a couple things. It's looking at our Azure.yaml, and the Azure.yaml says, okay, you're going to deploy this source code to a container app. And then it's also looking at all the infra that is in this infra folder. So this is using Bicep, which is an infrastructure as code language, which is a lot like Terraform, if you know Terraform. And this declares all the infrastructure we're going to make. So you can see we're making a Postgres flexible server. We're setting up a log analytics workspace. We're making container apps in a container apps environment. And we're setting up a key vault to store a couple secrets. And there we go. So azd up, I need to pick my subscription and then my location. And now the first step is actually building the Docker image. So it is looking at the source folder, because that's what we said we wanted to deploy. It's looking at the source folder and looking at the Docker file, and it actually built that image. And that's actually, if we look at our Docker, if we look at our Docker extension, we can even see it show up here. Let's see, registry. And Flask survey code space, Flask survey. Yeah, it's one of these in here. I think it's got made and listed here. Now the next thing it does is provision the Azure resources. So it is actually looking at the bicep and creating resources based off of what it sees in the bicep. So you can see first it makes that resource group. That's just based off the name we gave it. And now it's going to make everything else that goes inside of it. Now this can take a little bit of time. Like I don't often make through the whole AZD up in a stream, but we'll let it go and see how long it makes. I do, of course, have a pre-baked one. So I'll go ahead and bring up the pre-baked one so we can see what that looks like. Oh, no, that's the key vault. We don't want that one. We want this URI here. Okay, so this is one I deployed earlier. This is different from the one that has the hair survey. So I've got like 3 different ones of these at least deployed on container apps right now. But yeah, so this is the container app deployed. And so we should be able to create a new survey and put some awesome stuff in it here. And that created the survey in the database. So let's go ahead and look at what that architecture looks like in the actual portal. So we go and we're going to go look it up. Let's find that just the resource group. So you can see in the resource group, we've got the container app environment, the container app. Let's see, we've got a managed identity that we're using. We've got the flexible server, Postgres flexible server. We've got a key vault, and we've got the registry, right? So let's go ahead and look at the registry. I wonder, can we even like look at images here? I don't know if you can look at images here. It would be cool, but yeah, I don't think we can look at images. But our image is in that registry. Let's look at the container app. And here we can see the container that is running. We can look at environment variables. So you can see DB host, DB user. So this is the Postgres it's communicating with. And the secrets are all referencing secrets, which are stored elsewhere because we don't want to just store them as a normal environment variable. We can, look at things like every container app has like a default health probe here. We can see the registry that it's getting it from. We can see the image in the registry. We can see the image tag. And we can set up scaling rules. So Azure Container Apps has really cool scaling rules where you can say like, what's the minimum number of replicas, what's the maximum of replicas. And when it sees that it's getting like requests over a certain amount, then it'll start spinning up more replicas, which is very cool. And we can, also look at the logs if we need to see what's going on in our app. Let's see, can we see that? Oh, there we go. So see this log? This log looks very similar to what we saw locally, right? So this is what's called the console log. So this is actually the log from the container itself. And so this is what we could look at to see if we were having any errors. And you can see this one is deploying a new one here. Okay. So you can go ahead and try that out yourself. Often I get asked about costs for things. So, with most of my templates, I try to have a cost section. So you can go at the bottom and look at costs. So you can see like container app, container registry, Postgres. So I'll say like Postgres, you do get like one free one. And then past that, it's the cheapest is usually about $12 a month. If you go beyond that free one. Container registry is basically like a kind of a flat fee per hour, depending on how many images you have. So I have a container registry on my personal account and I pay about $5 a month for it. So that's kind of the minimum you can pay for container registry. So that's actually the most expensive part for me for my personal account, because I'm using the like free Postgres. I'm using, very little usage on my container app because I just use it for my personal apps, which, unfortunately are not super popular. So for me, the most expensive part is actually the registry. I did do also a price off blog post like last year. Let's see if I can find that blog post here. Okay, hosting Python web apps on Azure, a price off, right? And this was looking at a couple ones. So, like container apps plus CDN, you can see I spent like $5 on the container registry. I spent less than that on the container app itself. And then I spent zero on the CDNs. The CDN was pretty affordable there, because CDNs can be really efficient. And then this other one where I was, using the free Postgres was zero for that, and then 12 for app service. So you definitely want to look into the pricing depending on what you're, working with, because all of our service have different kinds of pricing, and we do have a pricing calculator for it. But also, if you're deploying any of these things as, just demo apps to get started, make sure you take them back down when you're done so that you don't accidentally, spend more money than you need to just to try something out, right? So you can either take them down by deleting the whole resource group, or you can run AZD down. And AZD down should also be able to take down the whole resource group. All right, so you can try with that one. We also have a bunch of other container app templates. So I'll just go through a few to see what might interest you, what sort of architecture you're looking for, right? So I've got like a very simple FastAPI container. And that's just with, just setting up a single FastAPI app with a little endpoint. I've got several examples that set up container apps plus a CDN in front. So if you want to, use that architecture, you can check out those samples there. We have a huge number of templates that are basically the same app, but with infrastructure for all the ways you might want to host something, right? So these are all the ones that are on container apps. And so we've got Django plus, Postgres Flex, or Cosmos for Postgres, or this other option we didn't talk about, which is Postgres Container Apps add-on. So that's something, let's see if I can find the documentation about this. If you're using container apps, you can like kind of just add on this what's called like a sidecar container, and it's not necessarily for production. It's more geared at being like, kind of hobbyist or development level or staging level. But if you just wanted like stick a Postgres container into your container app environment, and it'll basically be kind of like doing the Docker. It's like setting up something similar to what we did with Docker Compose, like creating another container for Postgres inside your environment. And you can do that same thing for Kafka, Quadrant, and Redis, it looks like. Let me see if there's anything else listed here. Okay, or MariaDB, Milvus, Quadrant, Weaviate, Redis. So these are all ones that if you're already running the Azure Container App and you just want to like stick on another container that's running these, it's not going to be a managed service, so you don't really want to go to production with this, but this could be maybe a good fit for a staging environment or something like that. So that's yet another option for how to run your databases on container apps, but not for scale. So we've got infra set up for all of these combinations of Django, FastAPI, Flask, plus those databases. And we've even got one with MongoDB. And this one, if we look at the repo for this one, we can look at, how do we set up a Docker Compose for Mongo? So this shows an example, like if we were going to do a Docker Compose with Mongo, we'd bring in the Mongo image and have a different health check here. So we use this like ping command that we found, and that just pinged it to find out when it was okay. And yeah, so it's similar to Postgres, but using a different image and different health check and environment variables and all of that stuff. We've got container apps plus AI. I mean, really, like you can make anything into a container app, right? It's just a way of packaging things up into a Docker file. So you can really make a Docker file for anything. But these are all ones that I built that do use Azure Container Apps. So we've got, like FastAPI backend, like a simple full stack. We've got one that's using container apps built-in auth. So if you want to have a container app that users can log into, then you can use this built-in auth feature, and then you just get user sign in and user sign out just using this built-in feature. You don't have to write much code at all. So that's pretty cool. I've got another one that's using Redis. So this one, we can look at the Docker Compose for this one. Docker Compose is using Redis, right? So it's saying you can do a Docker Compose with Redis as well. So that uses Redis locally, and then in production uses Azure Cache for Redis, because that's our production managed service that's going to scale really well. I also have Langfuse running on Azure. So Langfuse is not a Microsoft service at all. Like we can go to langfuse.com. It's this monitoring platform for monitoring your LLMs. it's really nice. I really like it. I often use it when I'm trying to evaluate how like performance of LLMs. And they have a Docker image, right? So what I did was make it easy to deploy on Azure using their Docker image plus a connection to our Postgres. So it's saying like you can make container apps that point at existing images. So in this case, I don't have to build the image already exists. So I'm just telling, here is the already built image. So if you have a situation like that where the image already exists and you don't need to change the image at all, you can just refer to that image for the container app, and then it'll build based off of that. And then here is a bunch more resources on getting started with container apps and just containers generally. There are, so many ways of running containers on Azure that, there's just a lot of different ways that you could go about it. So, take a look at those links if you're interested. And so actually, I seem to, ending early today. Let's go ahead and check on a few things. We can check on the deploy. Let's see, where's our deploy going here? Oh, it did actually deploy. I'm pretty impressed, actually. That's remarkably fast. The next question is, will it work? Oh my gosh, and it even worked. Okay, so that's cool. I mean, I should have more faith, but sometimes you have issues with like availability, especially because I'm a Microsoft employee. Like sometimes we have more constraints for what we're allowed to provision because we give more capacity for external users, which is good. But it looks like this was able to deploy everything successfully and get started. So that's great. We can also go ahead and check on our live survey to see what we have here. Oh, wow. All right. Okay. So it looks like I'm going silver, which is luckily pretty close to blonde. So if you still want to contribute to that survey, aka.ms/ I think live survey app. But it's looking like it's gonna be silver. All right. Any questions? Any particular apps you want to pull up from the samples? Let me also show another great resource that I really like, container.training. So these are just course materials that, a Docker expert put together. And I just think they're really nice, really comprehensive. So if you want to go deeper into Docker, I did really like this container.training. It's a bunch of slides, but it's 857 slides. So I will admit, I haven't gotten through all 857 slides yet, but I learn a lot every time I attempt to go through them. So I do really like this material here. I've also gone through, like LinkedIn Learning and stuff like that. So there's definitely a lot of great resources out there for Docker. There's also the Docker, tutorials themselves. What else? Let's see if I've got any containers running, here. So that one's running. I mean, almost everything I have is a container. There's also, of course, there's a big overlap between containers and setting up dev containers, right? For everything we've been doing in this whole series, I've been using dev containers, and dev containers are actually Docker containers for your development environment, and that's their focus goal. So a lot of times what I do is that I set up a dev container for my development environment, and that's how I use Docker locally. Is that I actually almost never run Docker run locally. I only do it for this sort of workshop. When I'm developing locally, my way of doing that is to define a dev container. So you can see the way I do that is, let me make this bigger. We have this .dev container folder. So we put a .dev container folder inside our project, right? So imagine doing this for, whatever application you're building at work. And you put a dev container.json in there, and that defines everything about the environment. And that can either reference an image, a Docker file, or a Docker compose. So you can get as complex as you want, right? Like I'll show you the simplest one that I have is down here. I have all these playgrounds, right? For Python 3.12. So if we look at this one, Oh, actually, that's not even the simplest. Okay, I want like really, really, really simple. I don't even know if I have as simple as we can go, but let's try this one. This is my like Python project template. Okay, good. This is the simplest. So here we say this is the image, right? So if we're just going to be making a dev environment that uses a particular image, then we can just specify that there. The next step is to specify a Docker file. So, I'll do that for like this one should have like a Docker file that it references, right? So we go here. Oh, actually, that one even just used just an image too. Okay, let's see. This one, PG Vector Playground. Everything on my GitHub has dev containers now because I am obsessed with them. So if you were looking, oh, that one does Docker Compose. If you're looking for dev containers, this is a good place to go. All right, this one, we say we're going to build based off the Docker file, and the Docker file is here. And this is a really basic Docker file, but it's I can customize it if I need to. And then the most complex is to say that you're going to use a Docker Compose. And here we say, here's the Docker Compose file. This is the main service from that Docker Compose that we're going to be working inside of. Because when we're using a dev container inside VS Code, we end up inside one of the containers, basically. So if we look at that Docker Compose, we can see the services. We have the app service, which is the actual application code. And we have the DB service. So, this looks similar to what we have before, but here we're saying the app code is going to be based off this Docker file. We can customize that image. We are going to use a volume because we do want to have our code, hot reloading and all that stuff. And we have a network mode here to make sure we're sharing the network with the database. And then the database image here, I'm actually bringing in PG Vector because this is a application that uses vector search with Postgres. So I'm bringing a PG Vector image, versions Postgres 16. I once again set up the volume, and that's the same as before. The environment variables like before, and then I have the volume here. So it looks pretty similar to the one we were using here. The difference is that I'm using this for VS Code and for code spaces. So if you open up code spaces, it's going to use this dev container. So when I start up VS Code, it's going to auto detect that there's a dev container and offer to open inside the dev container. And so that's going to use this Docker Compose to build these multiple services. And then it's going to place me inside that app container. So I'm basically inside the app container right now that is running. So when I look at my Docker desktop locally, I have a ton of containers running usually because of all my VS Code work. But most of these containers are actually dev containers. So that is the way that I'm typically using Docker on a daily basis is via dev containers. And that's kind of my preferred way of doing it, is that for local development, I use a dev container, and that's where I've got the Docker Compose, and that sets everything up. And then I can be working inside that container when I'm inside VS Code or code spaces. And then for deployment, I'm only using a Docker file and then using managed services for stuff like Redis and Postgres. Okay, so that was my spiel on dev containers. And if you're interested in, for more on dev containers, we talk about them a lot on the VS Code Python Pulse stream, which is every other Friday. So definitely check that out and, come by. Those streams are really fun. And we cover lots of Python-y stuff. All right, so I think that's all I have for reels. So, plugs for things coming up. We've got the Spanish language version of this series. So if any of you speak Spanish or have friends that speak Spanish, this is all coming up in July with Victor, who's also been helping out in the chat. We also have one more version in this series coming up on Thursday, which is going to be about testing and Playwright. And then we also have the Securing AI series, and I'm going to try and remember I'm gonna get the active for that one. It was S1355. Oh, thank you. All right. 1355 rolls off the tongue. All right. Securing AI apps on Azure. So that's going to cover using keyless auth with managed identity, doing user login, user auth for a spa app, and deploying to a private network. So that should be really fun as well. So I hope to see all of you in the future in the chat. Bye, everyone.
Thanks everyone for joining us today. Thanks to Pamela for another awesome session. You can learn more about this series, view past episodes, and register for future sessions at the URL at the bottom of the screen. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find the link on the screen or in the chat. Our event code today was 22173. We'll see you on the 20th at this time for the next episode.